Assalamualaikum and good day. My name is Muhammad Najmi bin Nordin. My metric number is 2111728773 and today I will present about thermoset processing. So, what is thermoset processing? Thermoset processing is a manufacturing technique that involves the transformation of polymer materials into a durable and rigid state through a chemical reaction, resulting in a final product with exceptional heat resistance, dimensional stability, and mechanical strength. This intricate and multifaceted process encompasses the application of heat and pressure to mold and cure the thermosetting resin, inducing a cross-linking reaction that irreversibly solidifies the material and imparts superior structural integrity. The transformative nature of thermoset processing distinguishes it from thermoplastic method, as the cured thermoset material become resistant to subsequent melting, ensuring its permanence and suitable for diverse applications in industries such as automotive, aerospace, electronic, and construction. The meticulous control of temperature and curing time during thermoset processing is paramount, as it directly influences the material's final properties, including hardness, chemical resistance, and thermal stability, thereby allowing manufacturers to tailor the end product to meet specific performance requirements and industry standards. There are a few fiber composite processes that can produce fiber composite product, and two of them is filament winding and pultrusion. Firstly, we will discuss about filament winding. Filament winding is a manufacturing process used to produce composite material, particularly cylindrical structures like pipe, tank, and pressure vessel. The principle of filament winding involves the precise and controlled application of continuous reinforcement fiber onto a rotating mandrel or mold, accompanied by the simultaneous impregnation of this fiber with a resin matrix. The combination of fiber and resin creates a composite structure with enhanced strength, durability, and tailored mechanical properties. Next is the characteristic of the product produced from filament winding method. The product is cylindrical shape with hollow core due to the fiber wound around the rotating mandrel. Filament winding machine can be designed to accommodate large mandrel, which allow to produce large diameter product. Produce thermoset composite product with unidirectional fiber because the fiber source is singular direction, which is true guide. Product can have a few patterns such as polar, helical, hook, based on the arrangement of the continuous fiber. Each pattern determines the mechanical properties and performance of the final product. And lastly, the product attains excellent dimensional stability through the synergy of reinforcing material like glass fiber, epoxy resin. This combination ensures the product maintains its shape and dimensions effectively. This is the process flow for filament winding method, and the next slide will show you on how the process is done.
One of the processes used to make tubular products is filament winding. A filament is a fine strand of a material that looks like a thin wire. Filament winding involves pulling glass or polymer fiber strands through a resin tank, then winding the resin-covered fiber reinforcement onto a rotating shaft called a mandrel. As the resin gels and cures, it bonds the fiber filament windings and forms a rigid tube of fiber-reinforced polymer composite on the mandrel. When the resin is fully cured, the mandrel is removed, leaving a polymer composite tube. The filament windings can be clearly seen on this carbon fiber fishing rod. Filaments can be wound onto the mandrel at right angles to it, and filaments can be wound diagonally. Multiple layers may be laid in opposite directions so that each layer reinforces the one next to it.
However, the use of filament winding method also has its pros and cons. The first advantage is filament winding technique can have highly automated. High fiber volume laminators can be used in this process, with possible 60 to 80% that can contribute to increase the mechanical properties. Minimize material waste as the fiber are precisely placed on the mandrel according to the design requirement. The properties of filament wound product can be customized by varying the type of filament resin and winding pattern. This makes them a versatile material that can be used for a wide range of application. Versatility in material selection because it can accommodate a wide range of material including various types of fiber such as glass or carbon and resin system. This versatility allows manufacturers to tailor the composite material to specific performance. And the disadvantage of filament winding method is it is limited to producing closed and convex structures. It is not suitable for making open structure such as bathtub. Difficult to obtain uniform fiber distribution and resin content throughout the thickness of the laminate. Product may have contamination due to the open system process. High tooling cost due to the size of the mandrel. Bigger size of mandrel require higher cost. A lot of steps during processing make the production time longer compared to pultrusion process. The next processing method is pultrusion. Pultrusion is a continuous manufacturing process used to produce composite material with a constant cross-sectional shape. The process involves pulling reinforcement fiber such as fiberglass or carbon fiber through a resin bath and then through a shaping die. The resin coated fiber are then cured or hardened to create a strong and durable composite product with a consistent profile. This is the characteristic of product that produced from pultrusion method. The product has simple uniform cross-sectional structure as the product was shaped by pulling and extruded through the shaping die. Final product shape is fully determined by the die shape. The product is exceptionally lightweight, being 75% lighter than steel, yet it maintains high strength and durability. This is attributed to the natural strength of the reinforcing fiber used, which combine excellent strength with a lightweight composition. Product shape usually simple as the continuous nature of the process limit the ability to control fiber orientation. Could be continuous rod or bar shape of product according to the shape of die that have been used, as the final shape is fully determined by the heated die during the processing. Product may have surface mark or parting line at the joint segment, as some dies are segmented for easy assembly, disassembly, machining, and chrome plating. This is the process flow for pultrusion method, and the next slide will show you on how the process is done.
Unidirectional continuous fibers like glass and carbon are being pulled from the creel stand. Depending on the product type, woven fabrics, mats and surface fails are pulled from the shelves. The reinforcement package is pulled through a guide where the fibers and woven fabrics are placed precisely in relation to the profile cross-section. When the reinforcement is pulled into the die, the matrix is added by injection. The matrix includes thermosetting polymer resins as well as process and product-related additives. The injection method is a fully enclosed process that keeps evaporation of solvents at a minimum. This ensures a good work environment in comparison with traditional pultrusion, where reinforcement is led through an open bath containing the matrix. After the fibers are impregnated with the injected matrix, the entire product moves forward to the next zone in the process, where heating takes place and where the curing of the profile is accelerated. The pulling power needed to overcome friction in the processing equipment, and thus the driving force in the process, is provided by pullers placed outside the processing equipment. Pulling can be done by either belts or reciprocal pullers. Depending on the cross-sectional area of the produced profile, pulling force of up to 50 tons are possible. During the last phase of the process, the profiles are shortened by a saw mounted to move at the same speed as the profile being pulled out of the die. This ensures a continual process with no stops, even when cutting.
And the last part is the pros and cons of using pultrusion method. The advantage is fast cycle rate as it is continuous process and can be completely automated to get the finished part. It is suitable for making high volume composite part. More secure from contamination compared to filament winding because the resin bus is in closed process. Pultruded composite are perfect for lightweight structural application because of their remarkable strength and stiffness in relation of their weight. It produces low-cost conventional goods by utilizing inexpensive fiber and resin process. Pultruded composite are appropriate for outdoor application because of their exceptional resistance to corrosion and environment factor deterioration. They are an excellent option for maritime construction, chemical processing equipment, and building components since they have tolerate exposure to moisture, chemical, and UV radiation without losing their integrity. And the disadvantage is complex and tapered form are not possible to create as it only works well with items that have consistent cross-section all the way around. Very high tolerance part on the inside and outside dimension cannot be produced using pultrusion process. Structures requiring complex loading cannot be produced using this process because the properties are mostly limited to the axial direction. Less reinforcement compared to filament winding due to low volume of fiber uses per product. High initial investment because the pultrusion process requires specialized machinery and tooling. Each can involve significant initial investment. I think that's all for me. Thank you.